Good afternoon.
Morning.
Morning. We're doing Chapter 6 today. Chapter 6 is about factoring, as you can tell from the title right here. Now, you need to understand what the word factoring means, and we've used the word factor before. We used it in the last chapter when we were talking about exponents. Okay? A factor is a piece of a multiplication problem. Do you remember that? You do now. What you need to know is that when we talk about factoring, to factor means to express or to rewrite as a product. What does the word product means? Please don't fail me now. It means we're talking about multiplication, and a factor is a piece of that multiplication problem. So all we're doing today is talking about factoring. Now, I just want to start off with a nice little example. Like if I have 24x to the 7th. This is a monomial, it's just a single term, but I want to show you a few different ways of being able to rewrite this guy using multiplication. Now I can very simply rewrite this guy to say 24 times x to the 7th. These are two of its factors. This is one way I have of breaking this down. Is that the only way I can break this down? No. If I told you that one factor was 2x to the 4th, what would the other factor be that would make up the 24x to the 7th? What is that? 12x to the 3rd. Do y'all agree? I mean, this is all multiplication. We've said that the great thing about multiplication is the order doesn't matter, so I could say, 2 times 12 is a 24, and all these factors of x would be x to the 7th. Do y'all agree? What if I have negative 8x? If I said that's one of the factors, what would the other factor be?
32.
You're multiplying. So negative 8 times what would get back my positive 24? Negative 3, x to the what? 6th or 7th? I already have one factor of x. To have 7 total, I just need 6 more factors of x. Do you guys agree with that?
Yes.
Okay. So we have to be able to look at terms like this and see how are the different ways I have of breaking this down. I mean, this isn't an exhaustive list. I could keep going and write this in a lot of different ways. But I just want to kind of get your minds thinking about how to rewrite and look at things in terms of multiplication, not addition and subtraction when we're talking about these coefficients here. Okay? Now, a pretty big concept that we've had before is the distributive property. You guys remember that guy? Remember how I would take a product, multiplying across addition like this, and when I did that I would get AB plus AC. Do you guys remember that? So what you see is that you took this factor of A and you multiply that so it became a factor of the term AB and of the term AC. So these guys all contain a factor of A. Do y'all agree? Because I took it and I distributed the A. The problem that we have a lot of times with these statements like this is that we're so used to seeing them going that way. We see them going left to right. Don't forget that since this is an equality, this is an identity basically, we can go from right to left. Okay. So you're used to multiplying to get this. What I want to do now is I want to take this where I see they have a common factor, and I want to bring that factor out front. I'm going to do the distributive property going backwards. This is the foundation for everything we do in this chapter. So let's start off with this example. If I take 5x plus 15. Okay. Now, I hope that you guys agree with me that I can rewrite this to say
Plus 3.
5 times x plus 5 times 3. Do y'all agree? Isn't that the same thing? And the reason I wanted to write it this way is so that you can see that you have a factor of 5 in both of those terms. So if I use the distributive property going backwards, how could I rewrite this?
5 just use x plus
5 is that common factor on the outside, and then you have the x plus 3 on the inside. Now, if you think that maybe this isn't correct, how could you check your work? Distribute it, right? Multiply it back out. So 5 times x is my 5x, and 5 times 3 is my 15. Do y'all agree? Okay. Now what you may want to do is rewrite and use different colored pens or markers or whatever so that you can clearly see what that common factor is. What if I have this? 20x squared plus 7x. Is there something that these guys have in common? They both have an x in common. If you were to look at 20x squared, completely broken down in terms of its factors, this guy is made up of 2 times 2 times 5, and that gives me 20, right? And then you have 2 factors of x. If I look at 7x, that's just 7 times x. And so you see that within these factorizations, they both have a common factor of x, and that's that common factor that I would write outside in front of the parentheses. So if I factor out an x, or if I basically divide the x out of each of those terms, what would I have left?
20x plus 7.
Right, I would have 20x, because I had 20x squared. I had 2 factors of x. I just took out one of those guys, so it's 20x, plus 7 times x. Well, I'm taking the x factor off, and I have just the 7. Yes? What do you guys think? Shaking your head no? You don't like that?
No, I was shaking
You just got a groove in your head?
Sure.
See, now my head's going to a different song. Shake that groove thing, shake that groove thing. Yeah, yeah. Show 'em how. Never mind. You guys need to have lives that are more musical. You should figure out what kind of musical you want to be in. Do you want to be in, Mary Poppins Mostly Happy musical? Do you want to be in, Little Shop of Horrors Alien Plant musical? Or it starts off happy, but we're being chased by Nazis, Sound of Music musical. So, looking at this example, look at the coefficients. What's the largest number that goes into 8 and 12? 4. And they both have factors of x, right? How many factors of x could I take out from each term?
3.
I could only take out 3. Why could I not take out 4? This guy could take out 4, right?
Because the other one only has 3.
He only has 3 factors of x. So if you try to take out more than these 3 factors of x, he doesn't have it, right? He's not made up of that. So if I have 8 divided by 4, what do I get? 2. I had 5 factors of x, but I took out 3, leaving with how many? X squared.
Minus 3.
And this is going to be minus 3 because I have a negative 12. When I factor out or divide out that 4, it's a negative 3. How many factors of x do I have left?
0.
I had 3. I took out 3. I don't have any left. Is there anything else that these guys have in common? Nothing else these guys have in common. So this 4x to the third is what we call the GCF. The GCF stands for the greatest common factor. This is the largest term that divides evenly into these guys.
I was going to ask if you go for the largest number versus just...
You always want to look for the largest number that goes into everybody evenly. Okay? 2 goes into 8 and 12, but 2 is not the largest number that goes into 8 and 12. Just like whenever you reduce a fraction, if I had this, if I said 8 over 12, what's the greatest common factor that you can reduce that by?
4.
4. And so this guy becomes 2/3 because you reduced by 4. Could you have gotten to 2/3 by dividing by 2? Or dividing by 2 over 2, but then doing it again, right? So you can still get there, and sometimes you see problems like that. Piece by piece, you still get there, but you always want to keep your eye open for the GCF, always.